We are currently about 82 million kilometers away from Earth, and in front of us is the least explored planet in the solar system. Its appearance may remind us of the Moon in some ways, and indeed Mercury shares many similarities with our satellite. However, upon closer inspection, numerous traces of asteroid bombardments become apparent. In this regard, Mercury is no less scarred than the Moon. Its craters have extensive radial systems, like the well-known craters such as Kuiper, Beethoven, and Rembrandt. Each crater tells us about its tumultuous past. If Mercury were not so close to the Sun, we might not have been as motivated to explore it actively. It perfectly fits the category of dwarf planets that revolve around the Sun far beyond Pluto's orbit. Despite its relatively close proximity to Earth, Mercury has left us with a multitude of mysteries that we may never be able to solve. The history of studying this planet began so long ago that even now, it's unknown who and when gave the name Mercury to the planet. It's reasonable to assume that it goes back to ancient times. After all, Mercury, in fact, never went anywhere and was observed by people as a bright and rare object visible during early dawn or just after sunset on certain days. This is precisely because it's situated close to the Sun. Its proximity to the Sun, by the way, hampers telescopic observation, not only from Earth, but also from space. For instance, the Hubble Space Telescope has never been and will never be used for observing Mercury. This is because its design doesn't allow for observations of objects too close to the Sun. Firstly, such observations wouldn't yield meaningful results, and secondly, it could result in equipment damage. Hence, the only viable means of closely observing, studying, and researching Mercury is through sending space probes to it. Of course, it's worth noting that in the latter half of the 20th century, radioastronomical and radar methods were actively employed. They allowed us to understand that Mercury has similarities in terms of its reflectivity index, similar to the Moon. This indicated the presence of an extremely thin atmosphere around the planet, which was later confirmed by spacecraft. However, all of this was not enough. Therefore, spacecraft were developed for the exploration of Mercury. Conducting such a space mission with sending a probe to Mercury was extremely complex. First, the spacecraft needed to decelerate to enter a highly elliptical orbit. Then, as it approached the planet, it had to be given an impulse to enter the planet's orbit. During the flight, the spacecraft would accumulate significant speed, and considering the weak gravitational pull of Mercury, it would require a lot of fuel for 2 maneuvers. In other words, the closer the planet is to the Sun, the more powerful gravitational forces the spacecraft must overcome to change its trajectory and speed. For example, sending a spacecraft to Mars is much easier than to Mercury. Therefore, Mercury was explored by a few spacecraft, which can be counted on the fingers of one hand. The first to approach Mercury was the automatic interplanetary station Mariner 10. At that time, it was a unique mission not only because of the flight to Mercury, but also because it was the first mission to visit 2 planets simultaneously. Mariner 10 used Venus to perform an auxiliary gravity assist maneuver, which is now a standard part of interplanetary flights. Take a look at the images that were taken along the way by Mariner 10. It flew past Mercury 3 times, with the closest approach being at a distance of 320 kilometers, lower than the orbit of the International Space Station, ISS. It was with Mariner 10's help that a map of nearly half of the planet's surface was compiled, confirming Mercury's visual resemblance to the Moon. However, unlike the Moon, more prominent and elongated cliffs were discovered on Mercury. By the way, Mariner 10 became the first spacecraft to transmit color and high-resolution digital images. Based on Mariner's data, scientists were able to determine the day and night temperatures more accurately and practically confirm the absence of a planetary atmosphere on Mercury. Mariner 10 determined that the nighttime temperature on Mercury is around -183 degrees Celsius, while the maximum daytime temperature reaches +187 degrees Celsius. Of course, later, temperatures on Mercury were determined more precisely. Using a magnetometer, Mariner 10 also obtained the first indicators of the planet's extremely weak magnetic field. The next spacecraft to study Mercury was Messenger, which took more than 6 years to make its journey from Earth to Mercury. As I mentioned before, Mercury is a very challenging planet for launching spacecraft, and currently, no spacecraft is capable of reaching it directly. Therefore, Messenger used 6 gravity assist maneuvers. I will probably tell you about these amazing maneuvers in a separate video. It took 6.5 years to reach Mercury's orbit, while a flight to Pluto, which is much farther away, would require more time. The New Horizons mission, on the other hand, took only 3 years more. Among its main and significant achievements are discovery of volatile elements evaporating at moderately high temperatures, detection of water ice in and around polar craters, compilation of a detailed map of Mercury's surface, with images of a significant portion being obtained for the first time, special interest in the Caloris Basin, one of the largest and youngest impact craters in the solar system, determination of the chemical composition of the surface and identification and study of traces of volcanic activity, study of the planet's exosphere and its variations with respect to the time of year and time of day, including the detection of exospheric nova tails caused by interaction with the solar wind. Investigation of Mercury's magnetosphere, confirming the dynamic mechanism of its formation. It was previously believed that the cooling process of Mercury's core had long been completed, and it was incapable of generating a magnetic field. However, Messenger discovered a displacement of the magnetic field from the planet's rotational axis. These are just some of the discoveries that Messenger brought to us, and we will talk about more of them later. An interesting fact is that due to the influence of the Sun's gravity, the orbit of any potential satellite around Mercury would change quite rapidly. In late 2014, Messenger ran out of fuel, making it impossible to correct its orbit. Gradually, it descended closer to the surface of Mercury, and on April 30, 2015, Messenger completed its mission by crashing into the planet's surface. According to specialists who worked with the Messenger at the Flight Control Center, that day was both celebratory and sad. It was the last time the team heard from the spacecraft, with which they had worked for over 4 years. Before its demise, Messenger was supposed to fly at a height of several kilometers over the Shakespeare impact crater, filled with solidified lava, and then collide with an unnamed ridge. If the crash onto Mercury had not occurred, the spacecraft would have emerged from behind Mercury as it fell on the planet's other side, invisible from Earth's perspective. Of course, the operators listened for signals from space, but as expected, the cosmos remained silent. The spacecraft's trajectory model proved to be accurate, and the gravity of the Sun played its role, ultimately sealing Messenger's fate. On October 20, 2018, the launch of a new mission to Mercury took place. It happened 2 years ago. We even made a special issue about the BepiColombo mission. It became the next step in exploring the planet closest to the Sun. To save fuel during the flight, BepiColombo will perform 9 gravitational maneuvers, once around Earth, twice around Venus, and 6 times around Mercury. It's worth noting that on April 10, 2020, the maneuver near Earth was successfully completed, and in October of this year, there is an expected encounter with Venus. Now let's talk about the uniqueness and mysteries of Mercury. Personally, for me, Mercury is a complete enigma. However, perhaps the most impressive factor is its movement. Mercury completes one orbit around the Sun in 88 Earth days. It also takes approximately 58.5 days to complete one rotation on its axis. Therefore, within one Mercury year, the planet manages to make only 1.5 rotations around its axis. Due to this, during perihelion, Mercury presents both sides to the Sun at different times. One Mercury day lasts 2 Mercury years, or 3 rotations around its axis. The time between 2 sunrises and sunsets on Mercury is 176 Earth days. So if you want to witness a sunrise and sunset on Mercury, you'll have to wait for about 176 days. But the wonders of Mercury's days don't end there. When passing through perihelion, the planet moves faster along its orbit than on remote sections. Its orbital speed starts to surpass its rotational speed relative to the Sun in the Mercurian sky. An observer stationed in one of the hot spots on the meridian can see how the Sun rises almost to the zenith, then moves in the opposite direction, and then turns around again, continuing its normal movement. But in other places on the planet, you can observe the Sun behaving differently. It rises, ascends not very high above the horizon, stops, moves in the opposite direction, sets, rises again, crosses the sky, and sets again. After that, it finally sets. Moreover, on Mercury, the sun appears twice as big as it does on Earth, and the sky remains black both day and night. This is because Mercury has almost no atmosphere and is surrounded only by the so-called exosphere, a space so thin that its neutral atoms never collide. According to observations through Earth's telescopes and during flybys of the planet by the Mariner 10 spacecraft, numerous helium atoms dominate the exosphere, but there are also atoms of hydrogen, oxygen, neon, sodium, and potassium. The atoms that make up the exosphere are knocked off the surface of Mercury by photons, ion particles from the solar wind, and micrometeoroids. The absence of an atmosphere on Mercury means there is no sound, since there is no elastic medium, like air, to transmit sound waves. However, the stars in Mercury's sky move 3 times faster than the sun. For example, a star appearing on the morning horizon at the same time as the sun will rise in the west before noon, earlier than the sun reaches its zenith, and will rise again in the east before the sun sets. Mercury's characteristics on the sky are intriguing, but the mystery lies in how it was formed. To attempt to answer this question, we need to look at its location when it is closest to the sun, which is 3 times closer than the distance between the sun and Earth. However, whether Mercury has always been on this orbit remains unknown. There have been various theories about the formation of Mercury, including the idea that it was once a moon of Venus. However, upon detailed study of Mercury, these theories have been refuted. Measurements taken by the Messenger spacecraft, which orbited Mercury from 2011 to 2015, revealed an unexpectedly high ratio of potassium to thorium on Mercury's surface. This is surprising because potassium is volatile at high temperatures, and on other solid planets in the solar system, its ratio to thorium decreases as they get closer to the sun. However, on Mercury, the ratio of potassium to thorium is similar to that found on Mars, a significantly colder planet. At the moment, no single model of Mercury's formation can fully explain this anomaly. Therefore, scientists hypothesize that Mercury may have formed much farther from the Sun, roughly in the same region as Mars, and then migrated to its current orbit, possibly due to a collision with a large body. Such a powerful collision could explain why Mercury has an unusually large internal core and a relatively thin outer shell. The core's diameter is about 4,000 kilometers, constituting over 55% of the planet's volume. For comparison, Earth's core has a diameter of approximately 1,200 kilometers. Therefore, it is possible that in the past, Mercury experienced a major collision, resulting in the loss of a significant portion of its outer shell, which would explain this puzzle. There has even been a hypothesis that this collision involved Earth, and the debris from it formed our moon. Another intriguing phenomenon of Mercury is its magnetic field, or rather, how it came to be. Not every planet has a magnetic field among the rocky planets in the solar system. Only Earth and Mercury possess it. Mars also had a magnetic field in the past, but it lost it. Mercury appears too small to have its own magnetic field, and though it is almost 100 times weaker than Earth's, it still exists. Earth's magnetic field is generated by a rapidly rotating liquid iron core at its center. Previously, it was believed that due to Mercury's significantly smaller size, it should have cooled down considerably, so there shouldn't be a liquid core at its center. Therefore, the existence of its magnetic field remained difficult to explain. To test if Mercury's core is partially molten, scientists attempted to observe small tidal deformations on its surface during the planet's orbit around the Sun and interactions with its gravitational pull. A slight bulge on its surface should be observed, and its size would vary depending on the distance from the Sun. According to estimates, the maximum height of this bulge should be about 14 meters, and the BepiColombo mission will be capable of measuring changes in this height over several Mercury years during its operation. Another mystery related to Mercury's magnetic field is that the center of the magnetic moment creating this field is not located at the planet's center, as it is with Earth. Instead, it is shifted toward the northern pole. Hence, we eagerly await the results of the BepiColombo mission to shed light on these fascinating aspects of Mercury. Another interesting aspect of Mercury is its water on the surface and whether it exists at all. The surface temperature is over 400 degrees Celsius, 752 degrees Fahrenheit, making it challenging to expect water or ice to be present. However, what's remarkable is that on the bottoms of many craters on Mercury, the Messenger spacecraft managed to observe faint glimmers resembling reflections of light from the surface of water ice. Nevertheless, Messenger couldn't directly confirm the presence of water since it lacked the necessary instruments. But these instruments will be on board the BepiColombo spacecraft, so it should definitively answer whether there is water on Mercury or not. Moreover, if water is present, BepiColombo will be able to estimate its quantity. In reality, the presence of water ice on a heated planet isn't as absurd as it might seem. The axis of rotation of Mercury is not tilted like Earth's, so the sun's rays hit the polar regions at a very shallow angle, providing less intense heating, especially within craters where sunlight may not reach at all. Therefore, a detailed analysis of the elemental composition of Mercury's surface might shed light on the origin of water ice there. Currently, scientists speculate that Mercury might not have had water initially, and that it was brought there, similar to Earth, mainly by comets. However, this remains just one version and is not 100% plausible. Another hypothesis suggests that asteroids, occasionally falling on Mercury, could be a source of the ice. Due to low temperatures in the crater bottoms, water might have persisted for tens of millions of years. Of course, BepiColombo will not provide a definitive answer to the nature of water ice on Mercury, but it will get us closer to finding an answer. Often, the surrounding world appears ordinary and mundane to its inhabitants. However, once you take a closer look at it, everything turns out to be quite different. For a long time, we believed that our solar system was just one of many star systems in the Milky Way. It contains rocky planets as usual and gas giants as well. However, soon astronomy made significant progress in studying and modeling planetary orbits, and it turned out that our system is extraordinary, not merely because it houses Earth with intelligent beings. It all started with Jupiter. Its orbit deviates significantly from being circular. Its elongation, scientifically known as eccentricity, is 3 times greater than that of Earth. We know that it is challenging to alter the orbit of a celestial body, especially if it has a substantial mass. And the more massive it is, the harder it is to change its orbit. In the early days of the solar system, when young planets were forming from the protoplanetary disk, they had flat, circular orbits. To achieve their current elongation, there must have been some gravitational interaction with another object. Jupiter's mass exceeds that of Earth by 318 times, and all other planets in the solar system by 2.5 times. To stretch its orbit to such an extent, gravitational interactions of colossal scales are needed. But with whom? What planet could be massive enough to influence Jupiter? Uranus and Neptune are also peculiar. According to calculations, they should have taken longer to form in their current positions than the protoplanetary disk could have existed. The only reasonable explanation for this paradox is to assume that they first formed much closer to the Sun and then migrated farther away. But the main mystery in our system is Mars. Also, the rocky planets in general follow a pattern. The farther a planet is from the Sun, the more massive it is. This makes sense because the farther a certain part of the protoplanetary cloud is from the star, the less material from that part of the cloud will be expelled by the star's radiation and solar wind. At first glance, this pattern holds true. Mercury is 15 times lighter than Venus, and Venus is 1.18 times lighter than Earth. But then we have Mars. Here, the regularity breaks. It is 9 times lighter than our planet. Certainly, some issues can be resolved by suggesting that Jupiter's gravity pushed away from Mars some part of the planetesimals, the small bodies from which Earth-type planets were formed. However, calculations show that a planet comparable in size to Earth should have formed in Mars' place, and the issue is not with the calculations or the theory. Mars lies within the habitable zone of the solar system. If it had an atmosphere comparable to Earth's, it would retain enough warmth to have a climate similar to Earth's arid regions. But in practice, its atmosphere is 150 times thinner than ours, and its gravity is too weak to hold a denser envelope. This is a fact. Clearly, if Mars were 5 to 9 times more massive than it is now, it would be inhabitable. Observations of other planetary systems show that planets the size of Earth, Venus, Mars, and Mercury are a significant rarity. Rocky worlds usually have masses noticeably larger than Earth's, earning them the name super-Earths. So, are all the planets in our terrestrial group anomalies? Astronomers Michael Brown and Konstantin Batygin, supported by most global scientists, believe that a super-Earth exists in our solar system as well. However, it is incredibly distant from the Sun, hundreds of times farther from Earth, and tens of times farther from Neptune. In other systems, planetary migration, moving closer or farther from their stars, is, surprisingly, a common occurrence. A whole class of planets called hot Jupiters exists only due to their migrations toward their stars, but our Sun has none. Gas giants cannot form close to a star because radiation blows away light elements to more distant regions. However, after formation, a gas giant might lose orbital stability and collide with planetesimals that gradually slow down its rotation around the star. As the planet's rotational speed decreases, it carves out concentric circles around its star, while its gravity ejects objects encountered along the way from the system. As a result, hot Jupiters often leave their stars without terrestrial planets and get so close to them that they heat up to thousands of degrees. This scenario paints a clear picture. Our system might have been quite different at the beginning. The giant planets didn't necessarily originate where they are now. Astronomers have constructed several detailed mathematical models of the movement of bodies in the solar system and made an unexpected discovery. From the perspective of celestial mechanics, the original formation region of Jupiter, the one that would be compatible with its current eccentricity and orbital position, is located at a distance of only 3.5 astronomical units from the Sun, meaning 3.5 times farther than the current distance between Earth and the star. However, Jupiter is currently at an average distance of 5.2 astronomical units from the Sun, which is 250 million kilometers farther away. So, how did it end up there? Here, computer modeling came in handy. Collisions with planetesimals slowed down Jupiter's rotation around the Sun, causing the planet to move on its orbit more slowly and, consequently, start to approach the Sun. On its way inward, Jupiter's gravity caught up with Saturn. Terrestrial planets form more slowly than gas giants and complete their formation after them. Therefore, Earth and Mars were somewhat lucky. If they existed at that time, they would have been in danger. Jupiter stopped at a mere 1.5 astronomical units from the Sun, slightly closer than Mars. The formed planets would have received too strong a gravitational impulse from Jupiter, and their orbits would have been too unstable. There was a high chance they would be ejected from the system. Nevertheless, Jupiter's migration caused significant difficulties for the unborn rocky planets. Its gravity did its job. Gas and dust from this part of the protoplanetary disk were literally absorbed by Jupiter, and some of the planetesimals were thrown out of the system. The region where Mars formed was so depleted of material that it ended up significantly smaller than Earth. But then why did Jupiter not stay at 1.5 astronomical units from the Sun and instead turn back? The explanation is straightforward. Saturn, following Jupiter, eventually entered into an orbital resonance with it. This means that Saturn's period of 2 orbits around the Sun became equal to 3 rotations of Jupiter, a 3-4-2 resonance. The presence of orbital resonance means that the bodies regularly align with each other. The gravitational interaction between them sharply increases, and their orbits receive significant corrections. The interaction with Saturn pulled Jupiter back just in time. Imagine what would have happened if the largest gas giant didn't stop at 1.5 astronomical units, but reached 1 unit, that is, Earth's orbit. Perhaps there would be no one to ask questions in that case. Earth would have been a small planet like Mars, and fortunately, Jupiter's walk would not have left much material for its formation. If life existed on it, it would hardly be as developed as it is today. Some believe that Jupiter is Earth's protector, safeguarding the planet from asteroid impacts. Well, then Saturn becomes Earth's savior. Such a journey of Jupiter couldn't help but influence Uranus and Neptune. Initially, they were not farther than 17 astronomical units from the Sun. The migrations of Jupiter and Saturn eventually threw them onto more distant orbits. They remain there today, Uranus at an average distance of 19 astronomical units from the Sun, and Neptune at 30. But what about the presence of super-Earths in the solar system? This is the most massive class of planets, but there is not a single one in our system. They form faster than the smaller bodies of the terrestrial group, so by the beginning of Jupiter's migration, they could have already existed in our system. In this case, an unfortunate fate awaited them. They were destined to be destroyed by falling onto the Sun. The remaining material of the protoplanetary disk in the regions where rocky planets formed in the solar system was too little to form a second generation of super-Earths. All it managed to do was to form 4 planets, with Earth accounting for approximately half of the total mass. However, things are not as straightforward as they seem. Practically any computer modeling of early migrations in the solar system indicates that its current configuration is unlikely. According to the most plausible scenario, the planets should have been on different orbits with slightly different eccentricities. Astronomers pondered this problem for a long time until they tried introducing additional planets into the modeling. It turned out that with the presence of 5 giant planets in the early solar system, instead of 4 as it is today, the probability of the system forming in its current state increases significantly. Almost certainly, some 4.6 billion years ago, there were indeed 5 such planets, and the 5th one was an ice giant, similar to Uranus or Neptune. Moreover, astronomers Betigen and Brown, who proposed the hypothesis of the 9th planet orbiting hundreds of astronomical units from the Sun, note that it is most likely a large object, or one of them, that was once ejected by Jupiter's great journey there and back. So, practically the entire architecture of the solar system was determined by events that occurred before Earth even existed. In the place where Mercury, Venus, our planet, and Mars are now, there might have been super-Earths, possibly more than one. At that time, there were 5 giant planets, not 4. The chaotic migration of Jupiter and Saturn destroyed all ancient super-Earths, casting them into the Sun, and at the same time expelled the current 9th planet of the solar system. Jupiter and Saturn themselves moved away from the Sun, and Uranus and Neptune moved even farther. It turns out that the migration of giant planets is the key mechanism that governs the scenario of planetary system evolution. Those systems with hot Jupiters may be devoid of terrestrial planets and chances of habitability. Their giant planets are so hot because their migration ended close to the star. They did not have their own Saturn to reverse their orbits. The constant presence of giant planets on orbits close to the star makes the presence of smaller rocky planets within the habitable zone even less likely. However, there are systems where giant planet migrations did not occur at all. In such cases, super-Earths are formed on orbits close to the star. The most well-known system with such a setup is TRAPPIST-1, located 40 light-years away from Earth. It is still unknown how habitable they are, but if they are, there might be more than one habitable planet in such systems, sometimes even more than 2. Whether this is true or not, we may find out in the coming years, thanks to the James Webb Space Telescope, which will soon begin its work. Before the era of mass exoplanet discoveries, scientists widely believed that the solar system was a favorable place for the formation of Earth-like planets and life. However, today, knowing about the Great Migration of Jupiter, this hypothesis seems less plausible. Earth miraculously avoided destruction and was not ejected into interstellar space. It appears that the birth of a habitable home in our system was an extraordinarily challenging process, and the number of planets suitable for habitation here is noticeably lower than what one might expect in more stable systems. Scientists studying space believe that there must be life forms somewhere other than Earth. With the era of space exploration in full swing, humanity is searching for traces of life within our solar system. Among the many planets, the most likely place to find life is Mars. So why do scientists believe that there is a high possibility of life on Mars? In the late 19th century, astronomers observed Mars through telescopes and discovered that it rotates on its axis and its tilt is similar to Earth's. They also observed that Mars had seasons, which indicated that Mars has an atmosphere similar to Earth. These observations suggested that Mars is like a second Earth with its own unique features. In addition, in 1877, Mars moons Phobos and Deimos were discovered, further increasing interest in Mars. Since then, scientists have continued to observe Mars and have found evidence of water on its surface, leading to the possibility of the existence of life on the planet. I discovered that some areas of the surface were bright, while others were dark, and at the time, scholars believed these to be continents. They also thought that Mars had a dense atmosphere, and when they continued to observe Mars, they believed that the changing colors on the surface were due to the seasonal changes of plants on Mars. In October 1895, the American astronomer Percival Lowell made the following claim: "Through my telescope, I have watched Mars for a long time, and I am sure that there are canals made by Martians, and on the planet there is a civilization, and Martians live in society." In the 18th century and early 19th century, scientists had debated whether or not there was evidence of life on Mars. However, as humanity's space technology rapidly advanced, some scientists began to argue that we should go to Mars to find out firsthand. The first country to attempt to explore Mars was the Soviet Union in the 1960s, but they experienced many failures. Starting from the atmosphere, now the US is starting its exploration of Mars. Oh, the Thomas exploration is not an easy task. Oh, it's not some cheesy talk on a Friday night. But we're talking about the only light young king out there. Should we book a cell and go to Mars first? Although the Soviet Union started exploring Mars 4 years before the US did, the US was the first to achieve results. In 1965, the US's Mariner 4 became the first spacecraft to approach Mars closely and send back images to Earth. The photos taken at that time totaled 22, but since it was an era of black and white photography, the image quality was not very good. Then, in November 1971, the US's Mariner 9 became the first spacecraft to successfully enter Mars orbit and sent back an enormous amount of data to Earth, including only 9 photos out of 7,300 taken, capturing about 80% of the Martian surface. The photos taken are diverse, including impact craters, the largest volcano in the solar system, Olympus Mons, and the erosion and deposition that occurred, almost showing the entire Martian surface. During this time, the Soviet Union was also tirelessly pursuing Mars exploration, but they didn't achieve significant results. Now, the United States, with billions of dollars, is embarking on the ambitious Viking project, focused on searching for extraterrestrial life. After the successful landing in 1980, Mars became a utopia. They successfully landed on the plains and immediately transmitted nearly 16,000 images back to Earth. In 1976, Viking 1 and Viking 2 successfully landed on Mars. After landing, they began searching for signs of life on Mars. They collected samples from the Martian surface and analyzed the atmosphere, but they couldn't find any trace of organic matter. However, the Viking lander had a fatal problem of being unable to move after landing. With all the exploration they're doing on Mars, it seems like they won't be satisfied with just one purpose. For the Mars exploration, NASA sent a rover with 6 wheels to actively explore various places. That's how the Mars Pathfinder was launched, with the intention of exploring multiple locations. The Pathfinder landed on Mars in July 1997. The Sojourner rover traveled around various locations on Mars for about 3 months, researching the atmosphere, soil, and rocks in search of life forms. However, once again, they did not find any friends of any life forms. Nevertheless, there were still significant achievements. It was revealed that the Homestake event occurred about 3 million years ago, causing erosion that created the Ares Vallis. This means that our existence on Mars had an impact. After the success of the Mars Pathfinder, humanity continued to send exploration missions to Mars. The goal is to explore Mars itself or find evidence of water or life on Mars. First, Mars Odyssey found evidence of water and ice on the surface of Mars from orbit. In 2003, the European Space Agency's Mars Express mission discovered water molecules at the south pole of Mars and succeeded in capturing images of ice. In 2008, NASA's Phoenix mission landed at the Martian North Pole, where it found water and ice and collected samples from the surface. The purpose of studying these Martian samples is to determine whether there is life on Mars or whether it could support life. Next, the Cassini mission discovered that methane levels on Mars vary significantly with the seasons. On Earth, methane is mostly produced by animal waste or the decay of organic matter. Therefore, methane is a powerful indicator of life. Of course, methane could also be produced geologically. Currently, researchers are actively studying where this methane comes from and whether it is produced geologically or by living organisms. Humans have sent dozens of Mars probes so far, but we have never found any signs of life or even traces of it. Why is there no life on Mars? First of all, it is very unlikely for Mars to be habitable. Its mass is only 1/10 that of Earth, and its gravity is only 1/3 that of Earth's. If a 70 kilograms person goes to Mars, their weight would become only 26 kilograms. Because of the weak gravity, Mars cannot hold on to its atmosphere, which gradually escapes into space. Second, Mars is much colder than Earth, and its magnetic field is very weak, only 1/80/100 of Earth's. With such a weak magnetic field, Mars cannot block the solar wind, which causes the atmosphere to disappear. As a result, there is hardly any air on Mars. Of course, Mars has some potential for becoming habitable, and we are actively researching whether there is any microbial life on the planet, or whether it could support life in the future. Earth-like, Mars has carbon dioxide and water vapor in its atmosphere, and even oxygen. However, the atmospheric pressure on the Martian surface is only about 0.006 times that of Earth's surface pressure, which is only 0.75%. With such thin air, it would be impossible for any living organism to survive. Compared to the Earth's environment, the Martian atmosphere is almost like a vacuum. This thin atmosphere also lowers the boiling point of water on Mars. The boiling point of water on Mars is only 27 degrees Celsius, so if humans were to be exposed to Mars's atmosphere, the water inside their bodies could be sucked out. It's really amazing. Another interesting fact is that the boiling point is the temperature at which the vapor pressure of a liquid equals the external pressure. If the external pressure decreases, the vapor pressure also decreases, so the boiling point decreases as well. In such an environment, even the most resilient organisms that are said to have high human survivability would find it very difficult to survive for an extended period of time. Mars also has extremely harsh temperatures. The average temperature on Mars is -80 degrees Celsius, and the surface temperature can drop as low as -140 degrees Celsius and rise up to 20 degrees Celsius. This temperature fluctuation is due to the thinness of the Martian atmosphere, which means that the molecules that make up the atmosphere are narrow and have less kinetic energy to maintain temperature and heat. This is why scientists have come to the conclusion that there is a very high likelihood that there is no life on Mars, as they have been studying the planet's physical characteristics since the 1960s, when they began sending Mars exploration probes. Today's video discusses the process of exploring life on Mars by our Parliament, and why scientists have determined that the possibility of life on Mars is very low. However, there are some who still insist that humans must colonize Mars, despite its harsh environment, and one such person is Elon Musk of SpaceX. On Saturn's moon Titan, there are both land and seas, as well as 6 elements that are abundant, so scientists believe that there is a high possibility of life on Titan. Let's take a closer look at the possibility of life on Titan. Titan, a moon of Saturn, is huge, second only to Ganymede in size among moons in the solar system. With a radius of about 2,575 kilometers, it is 1.5 times larger than the Moon and about 40% the size of the Earth. Although it can be observed from Earth, it is difficult to observe Titan's interior properly because of its thick atmosphere. Therefore, Titan was a mysterious celestial body shrouded in mystery for a while. However, in 1997, the European Space Agency and NASA launched the Cassini spacecraft to explore Saturn and its moons, and this spacecraft visited Titan. Hundreds of photos and atmospheric composition analysis were sent to Earth, revealing its identity. The image of Titan sent by the Cassini spacecraft was quite ordinary, with mostly wide plains and sand dunes created by the wind in low-lying areas. There were even mountains as high as 3,330 meters. At first glance, these photos looked like hazy days on Earth with dust or fine dust. Clouds were also observed in the sky of Titan. Weather phenomena occurred on Titan similar to those on Earth, with rain falling and lakes forming on the plains, and even seas forming in low-lying areas. Like Earth, liquid circulation also occurs on Titan. With this information, it seems that the speculations of Professor Carl Sagan, who was always right about the possibility of life on Titan, were not true. Or perhaps humans on Earth will one day be able to live on Titan. Because it is located as far as 1.4 billion kilometers away from the Sun, it doesn't receive enough solar heat properly. So as it turns out, the average temperature of Titan is minus 179 degrees Celsius. Titan can be called a supergiant freezer. Normally, if the temperature is minus 179 degrees, all the clothes on this satellite should freeze. Clouds 3 and oceans confirmed through Cassini 5 have a significant discrepancy with what we usually know. The hills on Titan were formed by completely freezing, and the seas on Titan were made up of methane. Also, the clouds were not white clouds gathered by water vapor like Earth, but had a murky appearance. When we only saw Titan in photos, we thought it could be habitable, but it's definitely not a place with a climate like Earth. Even though our environment is like this, scientists' opinions were very positive when Titan was discovered, except for Earth, as it is the only place where liquid is maintained on the surface in a stable way. This is the first celestial body that we confirmed, and there might be life forms here. Also, thanks to the layered structure of Titan, there are winds and rain, making it an optimal place for life. Now let's take a closer look at Titan. Titan has a dense, murky atmosphere. The atmospheric pressure is about 1.45 times that of Earth, and about 98% of the atmosphere is made up of nitrogen with trace amounts of methane. Interestingly, aside from Earth, Titan is the only celestial body in the solar system with nitrogen. Scientists say that Titan's nitrogen-rich atmosphere is very similar to the primitive atmosphere of Earth about 3.8 billion years ago. If we can analyze Titan's atmosphere, we can learn more about the changes in Earth's atmosphere. Currently, nitrogen is the most abundant gas in Earth's atmosphere, accounting for 78%, followed by oxygen at 21% and argon at 0.90%. These atmospheric compositions are present on Earth. However, these ratios have changed slightly over the course of several hundred million to billions of years. Titan's dense nitrogen atmosphere causes a greenhouse effect, which maintains a high temperature despite receiving very little solar radiation. This keeps methane in a liquid and gaseous state. If Titan did not have nitrogen, all of its methane would have frozen, and Titan itself would have become a completely frozen celestial body. Amazingly, the study of Titan has even led to the discovery of some unique molecules that are essential for life formation, such as cyclopropanyl, which is composed of carbon and 2 hydrogen atoms. This molecule is an important building block for life and also serves as food for other organisms. Although cyclopropanyl is difficult to pronounce and understand, it is a crucial substance that cannot be overlooked in the formation of life in the universe, and has been observed occasionally in interstellar matter. However, except for Titan, there has been no discovery of such compounds in other celestial bodies, so it's really amazing and remarkable. Cyclopropanyl, composed of 2 carbon atoms and 2 hydrogen atoms, has been discovered in Titan's atmosphere using the ALMA radio telescope by NASA's research team. The discovery of this molecule, which is difficult to pronounce and has caused quite a stir, is an essential component of the formation of living organisms and can also serve as food for other organisms. Although it has occasionally been observed among interstellar substances in the universe, it has never been found in any other celestial body until now, except for Titan. This is really remarkable, especially considering that it has only been found in 2 places, Titan, which is similar to the primitive Earth environment, and some other celestial body. Moreover, many benzene compounds have also been detected. These compounds play a role in the formation of complex organic matter. In addition, there are other compounds such as argon and carbon monoxide in the atmosphere of Titan, which is conducive to the formation of organic matter during its evolution. It is an environment where organic matter formed during its evolution is falling like light snow. There is one more fact to note about Titan. It is that 82% of its surface is covered with organic matter. According to Dr. Rosalie Lopez, a NASA scientist, more than 82% of Titan's surface is composed of organic matter that has fallen from its atmosphere and has been transported by winds. This means that Titan's organic matter is very abundant, which suggests the possibility of the existence of living organisms. This is an exciting discovery that raises the possibility of the existence of microbial or other life forms. If such life forms were present, there would be abundant sources of food. Another important fact is that there are oceans on Titan. Prior to this, lakes were discovered on Titan, but now it has been revealed that there are oceans as well. If the liquid in these oceans seeps into the subsurface, it could provide sufficient conditions for the birth of life. While this liquid is not water, Titan is the only celestial body in our solar system, besides Earth, where liquid exists on the surface. Scientists have found that Titan's oceans are deeper than previously thought. In fact, during an investigation of one of Titan's seas, Kraken Mare, the equipment that was used to probe the sea was limited by its technological capabilities and was unable to reach the bottom, which is at least 300 meters deep. This is more than 7 times deeper than the average depth of the West Sea, which is approximately 43 meters. In addition, there are geological activities like volcanic activities in Titan, and if such visual activities occur, an ecosystem ranging from microorganisms that use organic matter around the hot springs as food to predators on top of them may have formed. From the beginning, including Titan, organic matter is very abundant, so if miraculously some organisms were discovered on Titan, an ecosystem of organisms and their mothers could have already formed in Titan's seas. The most important clue is this. Recently, it was found that after hydrogen descends from Titan's atmosphere, it disappears from the surface, according to the data collected by Cassini. Some scientists at JPL are claiming that this may be the result of primitive life breathing in and consuming material on the surface. However, Titan's flowing liquid is methane, so if life is actually emerging and surviving here on Titan, the living organisms of Titan may be based on methane. Scientists are looking at Titan's existence of life with a very positive outlook. NASA has started the Dragonfly project to explore the seas of Titan. They will fly a kind of drone powered by a blue-tone fuel to observe various terrains of Titan. The Dragonfly project is expected to launch in 2026 and arrive near Saturn in 2034. They plan to use a parachute to land on Titan when the weather is favorable, and then switch to flight mode to explore and collect samples. Previously, Genius explorations were mostly conducted using ground vehicles, but this method had limitations in mobility, so the goal is to easily explore multiple locations. I will go crazy with my child's drone to explore. The target distance and time for the exploration are about 2 years, 7 months, and approximately 175 kilometers. This distance is twice the distance traveled by all Mars rovers so far. NASA hasn't made a final decision yet, but they say they could send a 1-ton submarine to Titan. The purpose would be to explore the largest Kraken Mare Sea on Titan, which has a fairly deep depth from the beginning. A submarine would be 10 times better than a drone to explore it. If we explore the liquid methane ocean with a submarine, we could thoroughly examine the ocean floor. What do you think about the possibility of life on Titan, Saturn's moon? Imagine a stationary world, ancient, about 4.5 billion years old. It is barely warmed by the sun's rays and covered with a thick layer of ice. This world is smaller than our moon, but slightly larger than Pluto. Its name is Europa, the 6th moon of Jupiter, and one of the largest satellites in the solar system. But what is most interesting about this distant place is that it may harbor life, according to astronomers. Europa is considered one of the most promising places in the solar system to search for new forms of life, all because it has a vast ocean of salty water, ranging in depth from 60 to 160 kilometers. It is hidden beneath a layer of ice with a thickness of 16 to 30 kilometers, but it is still potentially suitable for life. Astronomers claim that water erupts from cracks in the icy crust and is ejected, making it potentially suitable for life. Of course, reaching such a deep environment will not be easy for missions. On the other hand, scientists already have evidence that there are much smaller bodies of water, likely located much closer to the surface of the Moon. They could be situated less than a kilometer beneath the ice. This news brings two positive aspects. Firstly, it increases the chances of life existing on Europa, and secondly, if true, it will make it easier for future missions to search for these life forms. The lead researcher, Riley Kohlberg, accidentally came across a presentation by a colleague who showed a photograph of double ridges on the surface of Europa. Kohlberg remembered seeing similar ridges on Earth, although they are rare on our planet. However, on Europa, they are much more abundant. Subsequent research allowed them to hypothesize that the ridges on Jupiter's moon may be the result of a specific cycle, similar to what occurs on Earth. In this cycle, liquid water freezes and then thaws inside the icy crust, which represents an environment with relatively high pressure. This causes the icy crust to move upwards, creating a two-ridge structure. At least, this is how it happens on Earth. If similar processes exist on Europa, it could indicate the presence of subsurface water. However, the temperature, pressure, and chemical composition on Europa are entirely different, and scientists still don't know how the ice behaves there. Therefore, they cannot understand the depth or size of the water pockets or the time required for freezing. However, it is clear that such a subsurface environment on Europa is likely protected from harsh radiation from Jupiter, which bombards the Moon's surface. This, in turn, increases the chances of life existing in Europa's subsurface. Now we can return to the fact that the ocean on Europa appears to be salty. The red streaks on the Moon's surface may have that color due to their chemical composition. Most likely, they represent a frozen mixture of water and salts. This is quite unusual because this composition does not correspond to any known substance here on Earth. As for the yellow patches on Europa's surface, they may be caused by the presence of sodium chloride. This substance is known to us as salt. Scientists have tried to recreate the conditions on Europa in the laboratory and found that by combining water, table salt, low temperatures, and high pressure, they could obtain a new form of solid crystals. This substance can exist both at the bottom of Europa's ocean and on its surface. However, apart from this information, researchers haven't been able to learn much more. We can only hope that we will find answers to some of these questions around 2030. It is around that time when the Europa Clipper mission, planned by NASA, may reach Europa. The mission plans to conduct several close flybys to determine whether there could be any form of life there in the next couple of years. Europa will be visited by a spacecraft from the European Space Agency. However, Europa is not the only place in the solar system where life may exist or have existed. On our planet, a large portion of this gas in the atmosphere is produced by living organisms, such as methane generated by digestive processes in animals. Scientists believe that methane existed in the Martian atmosphere for about 300 years, but in 2006 it nearly disappeared, about 600 times faster than researchers had anticipated. The question remains, what or who produced this gas, and where did it go? Another Martian mystery involves microbes that may be dormant beneath the surface of Mars. They could have sought refuge from cosmic radiation for millions of years. Scientists simulated conditions on Mars in laboratories to test whether this could be true, and they were amazed to discover that bacteria easily survived in such conditions for 280 million years. This means that if life existed on Mars, we could find evidence of it. Currently, Mars lacks flowing water, and cells or spores would simply dry out. Additionally, the surface temperature is similar to that of dry ice. In other words, the surface is extremely inhospitable. The most likely candidates for life on Mars, if any, are bacteria-like organisms nicknamed Conean due to their rugged nature. Now let's move on to Venus. In 2020, scientists announced that something was found in its toxic atmosphere that could indicate the presence of life. Unfortunately, there was no direct evidence, as there was no opportunity to collect microbial samples or capture images of extraterrestrial life. However, they claimed to have detected a chemical substance called phosphine on Venus, which is highly significant. If this gas is not formed as a result of previously unknown chemical processes, then some microbial life may be involved. Phosphine consists of 3 hydrogen atoms and 1 phosphorus atom. This gas is toxic to any terrestrial life form that requires oxygen, including us humans on our planet. Phosphine can be found in places where there is little or no oxygen, such as swamps and marshes. It is formed as a result of complex mixtures of bacteria living there. It can also be produced industrially. If we think about it, phosphine should not be present in the atmosphere of Venus at all. The formation of this gas requires specific pressure, temperature, and tons of hydrogen. It would not be surprising to find it on Saturn or Jupiter, known gas giants. On this planet, phosphine cannot form naturally, or rather, it may form in small quantities during volcanic eruptions, storms, explosions of minerals on the surface, or when meteorites enter the atmosphere. However, there cannot be as much phosphine as astronomers have calculated, and this should have raised suspicions among scientists. But they were too delighted with their discovery. Perhaps they believe that life may exist on Venus. However, even if this gas was created by some mysterious organisms, it remains a big question how they survived on Venus. On our planet, some microbes can thrive in an environment with only 5% acidity, but not more. However, Venus clouds are composed mostly of acid, with over 90% sulfuric acid. Moreover, the atmosphere of Venus is 50 times drier than the driest place on our home planet. In fact, in 2022, thanks to high-resolution telescopes, it was concluded that there is only a very small amount of phosphine in Venus' atmosphere. So we need to look for signs. In the past, Pluto was considered the 9th planet of the solar system, and astronomers actively discussed the hypothesis of a 10th planet. However, when Pluto was later demoted, astronomers began searching for the 9th planet once again. If the 9th planet truly exists, where is it and what kind of planet is it? What do we currently know about it? Let's get started. The planet X. Problems related to Uranus and Pluto. After the discovery of Neptune, the question of whether there exists a giant planet beyond Neptune's orbit troubled researchers. When you think about it, everything originated from the orbit of Uranus. It didn't match the calculations that were possible at the time, and this discrepancy led to the discovery of Neptune. However, it was soon realized that the mass of Neptune did not match the mass that would have been exerted by Uranus. The most diligent explorer of the planets beyond Neptune's orbit, that is, the entire outer solar system, was Percival Lowell. He searched and wandered for a long time, and in the end, didn't glimpse it, but left behind many valuable calculation results. After Lowell passed away in 1916, his calculations seemed to be fading away. In 1930, Clyde Tombaugh discovered Pluto, which was initially considered a very large celestial body. According to the initial calculations, Pluto had a diameter of about 8,000 kilometers, and its mass was similar to that of Mars. If an object of this size had mutual gravitational interactions, combined with the gravitational interaction of Neptune, it could explain the shape of Uranus's orbit. The enigmatic planet appeared to have been discovered, but not everything ended smoothly. The accurate mass of Pluto was constantly updated, and it even decreased each time. After the discovery of its moon, Charon, in 1978, researchers finally found the final value. As a result, Pluto turned out to have a mass smaller than not only Uranus, but even some large moons in the solar system. Even the moon itself had 6 times the weight of Pluto. So, the mystery of an unknown planet blocked the path of researchers, and many of them returned to what Lowell was doing 70 years ago. At that time, the existence of Planet X was evident, and many researchers believed it had been confirmed by calculations. The rest was just waiting for its discovery. Some researchers speculated that the planet they were looking for would have a mass similar to that of Mars and would be in the same region as Pluto. Other researchers guessed that the planet would have a much larger mass than Mars, but would be much farther from Pluto. Either way, they continued to uncover the entire enigma through numerous discussions. Researchers from both sides were greatly disappointed when Voyager 2 reached Neptune in 1989, and, based on the data collected by the probe in 1992, the mass of Neptune was recalculated based on the data. Researchers were greatly disappointed. It was found that there was an error of about 0.5%, and that happened to be the mass of Mars. It was the remaining piece of the puzzle, the mysterious planet. With the accurate mass of Neptune known, researchers recalculated the gravitational effect of Neptune on Pluto's orbit. Surprisingly, the anomalies disappeared. The calculated results matched the actual observed results, indicating that there was no need to consider a 10th planet. Thus, Lowell's hypothetical planet problem was resolved. But our story doesn't end here. New discoveries and new problems arose. In the years following the demotion of Pluto, the 9th planet wasn't a topic that readily came up among researchers. However, as time passed, more and more was learned. It's too early to conclude the story. In 1992, the exploration of the entire outer solar system began, revealing that the solar system doesn't end with Pluto. The most notable discovery among the newly found objects was Sedna, a dwarf planet with a diameter of about 1,000 kilometers. It had a highly eccentric orbit. The passage of time on Sedna, during one rotation around the Sun, is slightly shorter than 11,500 years. During its long journey, Sedna moves more than 900 astronomical units away from the Sun and gets as close as 76 astronomical units. The long elliptical orbit is not known to exist apart from the known comets. Another notable dwarf planet with a significant difference between its perihelion and aphelion distances was discovered, 2012 VP113. It moves about 446,000 astronomical units away from the Sun and gets as close as 80.6 astronomical units. Researchers have proposed various hypotheses to explain the factors that greatly elongate and distort the orbits of these dwarf planets. According to one theory, the Sun may have an unknown brown dwarf or a dark red dwarf as a partner celestial body. The distance between that star and the Sun could be very large, and we may not know exactly what kind of star it is. A good example that demonstrates the existence of such a star is Proxima Centauri, the closest neighbor to Earth in the Centaurus constellation. This star orbits around the binary stars Alpha Centauri A and Alpha Centauri B, located more than 12,000 astronomical units away from them. The hypothesis of an unknown partner star for the Sun is quite intriguing, and if you're interested, we can explore it further in another discussion. But for now, let's return to the hypothesis of a distant planet that can explain the peculiar elliptical orbits. In 2014, based on the calculations, researchers reached the conclusion that there is no unknown celestial body within a radius of 26,000 astronomical units from the Sun with a mass comparable to or larger than Jupiter, or a celestial body with a radius of 10,000 kilometers comparable to Saturn. However, there is still room for smaller objects with masses below that of Neptune. According to calculations by researchers, there may be a planet with 2 or 3 times the mass of Earth, orbiting around 500 astronomical units away from the Sun. If the mass of this object is larger, equivalent to 15 Earths, the distance from the Sun would be around 1,000 astronomical units. In both cases, considering the potential influence of smaller objects, the actual observational results can be explained. In the same year, astronomers noticed that 6 dwarf planets, including Sedna and 2012 VP113, in the outer regions of the solar system, orbit more than 250 astronomical units away from the Sun, have similar orbital characteristics, and move in nearly the same direction in space. This suggests that these objects are being shepherded by some celestial body and influenced by its gravity. However, despite all this, the enigmatic planet has not yet been discovered. Researchers speculate that this planet may be very dark. Interestingly, a similar hypothesis existed for Pluto as well. Astronomers considered the possibility that Pluto might be larger than expected. Recently, Chinese astronomers made a novel proposal. Instead of searching for the planet itself, they suggested looking for its satellites. An object with that mass could attract celestial bodies of about 200 kilometers in size from the scattered disk or the outer cloud, at least 20 of them. Such objects can be observed if the location is known. If successful, it would be an unprecedented event where the satellite of a celestial body is discovered before the body itself. With this, today's video comes to an end. My hypothetical planet would probably have a dark and dim appearance. If its mass is similar to Earth's, its surface would be solid and completely covered in ice. In the planet's sky, the sun would appear small, similar in size to other stars. There would be hardly any brightness greater than that of a full moon visible from Earth. The surface would be covered with frozen gases like nitrogen, carbon dioxide, or methane. There would be no significant heat transfer to melt the ice from the sun. If my hypothetical planet were a giant planet like Neptune, it is difficult to even imagine what kind of celestial body it would be. So we can only hope for new discoveries in the future. In our Milky Way galaxy alone, there are at least 300 million habitable planets. It can be assumed that over time, another civilization would be capable of achieving the technologies necessary for interstellar travel. Yet, humanity has never encountered extraterrestrial beings. These three unexplained facts are unified by the Fermi paradox. So, what can be inferred from this? Either they cannot or do not want to contact us. And what about ourselves? Throughout the time that scientists have been searching for extraterrestrial life, they have been envisioning it as a likeness of ourselves. One more important note. Until we delve deeper into the topic, let's not get too distracted by science fiction. At the same time, the problem of defining the conditions necessary for the emergence of life is being discussed and studied. This question is highly complex, as the answer is intertwined with terminology and the peculiarities of a scientific disciplinary approach. Renowned astronomer and historian of science, Stephen J. Dick, traced the history of debates on the definition of life throughout the 20th century in his book Life on Other Worlds. Among other things, he discusses an article by the evolutionary biologist George Gaylord Simpson when U.S. scientists began preparing for the search for life on Mars. Simpson argues that life forms in different conditions do not necessarily resemble familiar earthly forms. The primary definition of life, with which most biologists would agree, is that living organisms are characterized by the ability to grow and reproduce independently. However, even the applicability of this definition remains unclear for crystals, not to mention the extensive gray areas within biology itself. For example, it is unclear whether viruses, which have their own genome but are not capable of reproducing themselves independently, should be considered alive. It also seems that the aforementioned definition does not include so-called prions, which are single proteins capable of replication. It can also be noted that there is agreement among scientists that bacteria represent the most rudimentary form of life. Thus, the subject of debate extends not only to the definition of life, but also to the criteria for its emergence. Carbon is key. There is a persistent assumption that if extraterrestrial life exists, it should be similar to life on Earth. Specifically, the molecules responsible for life's chemical processes should primarily be composed of carbon. It is understandable that such a form of life is most familiar to us, making it extremely difficult for humans to imagine alternative biochemistry. Scientists speculate that we will be able to discover a habitable planet within 10 years. There is a high probability that it will orbit a red dwarf star. After all, these stars, which make up 80% of all stars, are most prevalent at relatively short distances from Earth. And most importantly, there could be life similar to ours there. So, there is a planet similar to Earth orbiting a red dwarf. In order for liquid water, a vital attribute of carbon-based life, to form on its surface, it must orbit close enough to its star. However, much closer than our planet does. After all, as we know, red dwarfs are much colder than the Sun. Therefore, under the influence of gravity, such a planet would not rotate around its axis and would always be facing one side towards its star. There would be no change of day and night or seasons. The second hypothetical object with life is the blue moon. It is a fictional moon of a Jupiter-like planet, almost entirely covered in water and having a very dense atmosphere. These conditions allow scientists to speculate about the existence of flying creatures the size of whales on the moon. The blue moon should be comparable in size to Earth, but according to the model, the atmospheric pressure on its surface is 3 times higher than on Earth. A characteristic feature of the moon is the absence of polar ice caps. The dense atmosphere and the ocean covering its surface reduce temperature fluctuations. The excess oxygen in the atmosphere theoretically should lead to increased muscle strength in celestial whales, whose wingspan reaches 10 meters. Billions of algae and moss float in this air, which serve as food for the celestial whales. It's a beautiful picture, of course. Silicon structure. But if we completely depart from the idea of carbon, what remains then? It turns out that scientists have delved into the concept of extraterrestrial life based not on carbon but on silicon. Science fiction authors have also been fond of this idea. It is strange, however, that literary silicon aliens, for unknown reasons, always resemble clay statues or animated crystals, even though from a scientific perspective, the external differences between silicon-based and protein-based beings could be minimal. After all, silicon is simply meant to replace carbon in organic molecules. And the substance that forms the flesh of silicoids, silicone, is widely used today to imitate certain human body tissues. Theoretically, the scorching worlds dissected by rivers of lava flowing at the base of black basalt rocks could be a natural home for silicoids. However, even on such planets, silicon-based life would not create a great civilization because hydrogen sulfide is rare, and a transition to synthesis based on water would be impossible. Water cannot coexist with magma. Other liquids. Interesting possibilities arise from replacing carbon with a combination of nitrogen and phosphorus. In this case, for plants to undergo photosynthesis, they would require ammonia and phosphine, a compound of phosphorus and hydrogen, instead of water and carbon dioxide. Life based on a phosphorus-nitrogen foundation could thrive in cold worlds similar to those described in Paul Anderson's novel 3 Worlds to Conquer and Kir Bulachev's story Snow Maiden. After all, ammonia freezes only at a temperature of -78 degrees Celsius. From a metabolic standpoint, nitrogenoids would be upside-down creatures. Terrestrial plants synthesize fuel, hydrocarbons, while producing oxygen as an oxidizer. However, in icy synthesis, hydrogen becomes redundant. By inhaling this highly efficient fuel, nitrogen beasts would need to extract oxidizer from plant-based food, returning nitrogen and phosphorus to the plants. The organic substances based on nitrogen and phosphorus, though, are not sufficiently stable, but only under terrestrial conditions. The reliability of chemical bonds increases as the temperature drops. Therefore, the nutrient broth necessary for the emergence of nitrogen-based life could accumulate in ammonia seas. However, the most suitable life form for realistic conditions is the alternative life in which oxygen is replaced by sulfur. It may seem like a minor detail, but in such a case, synthesis becomes possible only by replacing water, which turns into a lethal poison, with sulfuric acid. This means that suitable conditions for hypothetical sulfocarbon bacteria can be found on the neighboring planet, Venus. The clouds on waterless Venus consist of sulfuric acid. Another thought that arises is that during anoxic photosynthesis, sulfocarbon bacteria would release hydrogen sulfide instead of water vapor. However, hydrogen sulfide is an unstable compound that quickly breaks down due to cosmic radiation. Yet, hydrogen sulfide is present in the atmosphere of Venus for some reason. Its reserves cannot be replenished through volcanic eruptions because the planet's interior has cooled down and volcanic activity has long ceased due to the lack of a massive satellite. Could non-living creatures produce this gas? However, of course, hydrogen sulfide in the Venusian clouds may have a different, less exotic origin: bacteria. In general, Venus is a rather interesting planet. British scientists believe that the space at an altitude of 51 to 65 kilometers above the surface of Venus could be inhabitable. They have determined that the temperature there ranges from -20 to +65 degrees Celsius. The atmosphere is composed of water vapor heavily saturated with aerosols of sulfuric acid. It is under such conditions that extremophilic bacteria, which feed on sulfur, can survive. For example, the Archaeon pacrophilus, which inhabits hot brine pools on Hokkaido Island, On Earth, extremophiles occupy the most lifeless places, such as hot underground springs, anaerobic reservoirs, and permafrost. Some microbes have adapted to feed on inorganic substances, assimilating them with the help of solar energy. Venus lacks a strong magnetic field to protect it from the flux of high-energy galactic radiation. Solar flares there are more dangerous than on Earth, which has a more distant orbit. However, the atmosphere of the planet of crimson clouds is many times denser than Earth's and provides better radiation shielding. Scientists believe that there is still no chance of survival on the surface of Venus. Liquid oceans and a biosphere may have existed on early Venus, but subsequent greenhouse effects transformed it into a dry, sterile desert. It is unlikely that life has survived beneath the planet's surface or in the soil. The only place where it could potentially thrive is among the clouds high in the atmosphere. For example, bacteria like Mesophilic Deinococcus radiodurans can survive even when exposed to 10 kilograms of radiation. Hyperthermophilic archaea, like Thermococcus gametolerans, can reproduce at 88 degrees Celsius and withstand a radiation dose of 3 kilograms. So there is something to ponder upon, an alternative reality. Consider completely different realities, for instance, as mentioned by science fiction classics such as Stanislaw Lem in the story The Truth. These works mention beings composed of magnetic fields and molten plasma. In Lem's novel The Invincible, humans encounter a planet inhabited by feral and degenerated machines. Lem also describes Solaris, a sentient ocean that neither emits nor consumes anything as far as one can discern, except, of course, for curious researchers. In Fred Hoyle's novel The Black Cloud, signs of life emerge from a drifting gas cloud in space. The common characteristic of all these non-chemical creatures is their mysterious and likely artificial origin. Intelligent beings do not arise by chance. Complexity must arise from simplicity, and the only known path to complexity from simplicity is evolution. However, it is unclear what would serve as the carrier of heredity within a plasma clot and how a gas cloud or an ocean could undergo mutations and natural selection. Alternatively, consider the dark idea expressed in horror games such as Quake, Dead Space, or Doom, where extraterrestrial life forms are unpleasant for humans. The human brain has numerous limitations. We are misled by cognitive biases, optical illusions, and blindness to things we are not ready to see. One question that has always haunted the study of extraterrestrial life is whether we can recognize life that is so different from what we encounter here on Earth. Scientists have long urged us to expect the unexpected. Life on other planets may not leave the same biological traces as earthly organisms, making their detection challenging from our perspective. And if this life has also transcended the bounds of the material world, it becomes an incomprehensible phenomenon for us. Today, the search for potentially habitable exoplanets continues, and some fairly effective methods for their detection have already been developed. The big question is how many more Earth-like planets exist that can be discovered. After that, the question arises about their habitability and what form life could take on these planets. The laws of physics are universal. The 12 fundamental quantum particles, with their unique fields, and the 4 types of fundamental interactions form the basis of matter. It is these elements that make our world the way it is, and no different. Regardless of what we discuss, whether it's our planet or the most remote corners of the universe, the same laws apply everywhere. All the observations and experiments conducted by humans over the past few centuries, whether with a telescope or a microscope, only confirm this thesis. Perhaps the hyper-intelligent extraterrestrial life of an alien being will seem unfathomable and complex to us, as in Stanislaw Lem's novel Solaris. But one thing is clear, we still have a long way to go to establish the first productive contact, or perhaps simply dispel all our dreams about it.